So question 10 moves into a different type of special product. Determine whether the following trinomial is a perfect square. So one of the things we have done in our classes is we've kind of used FOIL for things. So like if I gave you x plus 3 squared, that's the same thing as x plus 3 times x plus 3, which means we could use FOIL on this. We can multiply the x through, so that's the f and the o. And then we can multiply the 3 through, and that's the I and the L. So that's our F and O, I and L, FOIL. So doing that by hand, we know x times x is the same thing as x to the power 2 because the power 2 means there's two x's connected by multiplication, so that's the simple form of x times x. Outer, 3 times x, we just write that as 3 times x. And then I usually start a new row. 3 times x is going to be 3x, and then 3 times 3 would be 9. So if we do this out, notice how we have x squared plus 6x plus 9. So what we kind of notice here is there's a pattern. When you square a binomial, it's going to turn into a trinomial. The pattern is we square the first term, x times x is x squared. To get to 6x, what we do is we multiply the 3 times the x and we double it. So there's going to be two 3x's, if you will. And then we can square the 3 and get the 9. So really the trick is that middle term, 2 3x is going to be the 6x. So x squared plus 6x plus 9 becomes the trinomial. So if I do another one, if I gave you, say, 2x plus 5 squared, notice we don't really have to use FOIL. We can actually recognize there's a pattern to it. The pattern is this formula a squared plus 2ab plus b squared is going to equal a plus b squared. So that's how we have this a plus b squared. So what we can do then to get the answer is use this formula where a is the 2x. So if we can just go 2x times 2x, that's 4x squared. And then to get the middle term, you got to go 2ab. In other words, 5 times 2x is 10x, and you have to double it. That'd be 20x. And then you have to square the 5, which is going to give me 25. So that's the same thing as 2x plus 5 squared. But notice over here, this is actually the factored form. This is the product. So if we look at this problem up here, we're trying to figure out if this actually factors into this special product form. But notice how we actually have two formulas. A squared plus 2ab plus b squared is going to be this a plus b squared. But notice how if we change the sign of the middle term, a squared minus this 2ab plus b squared, then it's actually going to factor into this a minus b squared. So we can use these shortcuts. So notice how to test this, it's actually got to pass 3 tests. So the first test is the first term of perfect square. Yeah, 5a squared gives me 25a squared. Then I turn my attention to the last term. Is the last term a perfect square? 4b squared does give me 16b squared, so passes that. Now the trick is, notice how we really are focusing more on this one, but notice how we have this 2ab. So really what you got to do is multiply the a and b together. So 5a times 4b, 5a times 4b, that's going to be 20ab. But the catch is you have to double it. You got to multiply that by 2. So if I multiply by that 2, does 2 20ab's give you 40ab? Yeah, it does give me 40ab. So this tells me that this is a perfect square trinomial, and it would factor into this 5a minus this 4b squared. So notice how it's just going to be a minus this b. So this is your a, if you will, and this is your b. And since there's a minus sign here, we use a minus sign between the two terms. So 5a minus 4b squared is our factored form of that. So to determine whether or not the following trinomial is a perfect square, yeah, this is a perfect square.